Oh, thanks everyone. Happy Friday. My name's Yaqi Chen. I'm trying to keep everyone engaged right before lunch. So hopefully it's an exciting thing for you. So a little bit about me always, not like I'm bragging about I'm leading a machine learning, those buzzwords, or I'm a PhD, what does that mean? But one interesting about me is I joined the top leading agriculture company as my first job. Roughly 10 years ago, as one of the machine learning, deep learning scientists, and people really didn't understand what that means. And I still remember those days where it took me like a full day to just configure my local dev environment. I have to configure the Cyano backend, and there are all kind of dependency conflicts, and I need to address one single of them and just keep the way it was. Like, don't touch it, don't touch my computer. And if another developer asks me to set up his, I'm like, I need to, consider really, really long time. Should I want to spend another 8 hours just on this again? So it's a very interesting journey. It's also kind of reflect how easy life is for data scientists. I sort of feel like I'm spoiled. Like you just pull the container and just run your Docker just everywhere you want to be. It will reproduce exactly what you want to do. So life is much easier right now. So I'm leading machine learning strategy at Object Computing. And in today's talk, I want to kind of show you some of the real-world challenges as we're kind of servicing our clients across different industries, and how we are going to tackle that, leveraging part of the machine learning lifecycle and some of the other kind of bespoke solutions that we're providing. And I'm going to walk through some case studies. And for those of you who are very familiar with this machine learning space, don't laugh at me. Just take a step back and try to pound the point I'm trying to make. And then I'm going to talk about our kind of solutions in terms of the product we're building here to make our clients' life easier, make everybody's life easier. Start with these industries. Maybe some of the other consultant companies are also facing the challenges that every industry has their own problem. There's different business segments we're seeing here. Take the agriculture as, because I knew that very, very well, and I see some of the old colleagues, hey Vijay, in this call, and he's going to mention that as in agriculture, people are really caring about product selection, so seed product. Why my field at Missouri is very different from your field as in Nebraska, because Nebraska always do irrigation, Missouri does not do that. So how would that make my seed selection a little bit different? We call that tailored solution, and that really poses very challenging problem, like how we should characterize your farm versus mine. So that's the very one of the problem in agriculture people are trying to tackle. And in healthcare, there's many problems in healthcare, and one of them is deals with computer vision. In computer vision, in healthcare industry, you look at X-ray, you look at MRI, but in agriculture, for the same computer vision problem, you're probably looking at satellite imagery, you're looking at drone, you're looking at some of the cell phone images. So they're both kind of in the broader categories of computer vision space, but they're dealing with totally different data. How the data are collected are very, very different. So how are we going to find the experts in different agriculture, in different industries, and try to develop these bespoke solutions that just to solve the problem? While one solution is you can just keep hiring. You're hiring the people that knows exactly what needs to happen in each industry. And however, it's hard really to find. I know a lot of companies today are really hiring for people. And for us, it's extremely hard to hire those. It's not hard to fire. It's also hard to fire, but it's extremely hard to hire people who know a little bit of everything, and we call those people unicorn people. I would be very happy if this person comes with one or two blended disciplines. I'll be very happy to just give this person an offer. I want to talk about machine learning lifecycle. I think the previous speaker also talked about that briefly, but I want to anchor on this because that's kind of the basic principle we're sticking with as our machine learning team is leading to this maturity level. So for those of you who are not familiar with machine learning lifecycle, this is one of the critical takeaways I want everybody to remember. There's another critical one. I'll mention that later. But there are basically 3 stages when we perform machine learning projects across organizations, across industries. It involves with data, involves with model, involves with deployment. So when you talk about data, you're talking about how are we going to discover different data sources? Are the data sources on-prem or they're on cloud? Or do I need to do something different in order to bring the data to the right shape? So some of the things you might be familiar with, like feature engineering, which I think is really the key and critical step in this overall success of machine learning performance. And those labeling like human annotation, we just assume the data are clean. That's how data scientists often think, but that's not the case. It takes efforts to label those data, to clean up those data and put them in a shape that are convenient for data scientists to build model upon. The modeling side is relatively, compared to the data set, it's actually the fun part because you got to try those cool models like computer vision in the convolutional neural network, in the LSTM, in the language space, and some other time series, and generative model, GAN model. Those are the coolest area data scientists want to spend their time on. And on the deployment side, there's a lot of ML ops side, how we make sure the model drifts is handled. There's not much bias and weird things happen after your model deployed. So a bunch of interesting cycle processes are happening in this cycle. In the next real world case study, I want to focus on the data and model part, and I will just put the deployment side just within the scope of this talk. So we take the machine learning lifecycle to the next level, because you can talk about these 3 different stages, but how, right? How are you going to map those basic principles to these different industries? So one approach we're taking at object computing is we actually see there are similar gists across these different industries. As much as the connections are illustrative, I want to give you an idea of different industries. They share different pipelines or solution buckets, and we identify those, and we have way complicated mapping than this, but just this is to give you a flavor of how would these different solution categories can map to different industries. Once you've done that kind of exercise, your life is actually much easier because you can reuse that solutions on new industries that you probably have little comfort level. However, once you understand the domain and SME side of things, reuse the solution you built for the previous industry or previous solutions is going to be much easier. So to further illustrate that, I want to go through it's a toy example, it's a case study, and I cannot go wrong with pets, right? It's actually a real world problem. We worked with a pet food company where they're trying to accelerate their adoption and food selection process. So automated computer vision and classification task about pet breed. So in this case, I want to simplify that. So we're having a bunch of pictures. I have a dog and cats, and in machine learning, in particular supervised learning. We call it supervised learning because it has labels. So you digitize those labels. You use 1 to say this is a dog, and you want 0 to say this is a cat. Okay, so that's where we start. And we assume there's an expert who knows very well about cats and dogs, and this guy has very generously put these nice pictures into 2 different folders, regardless it's your local drive or in cloud. Doesn't matter, but that's one of the challenges, or not much of a challenge, is reality you're facing is those images are going to be of different sizes, right? You cannot really control the person who's taking those images, so there are different field of view, and some people are really bad at taking pictures, so some of them can be super blurry, and some are not really having the object in the middle of the field of view, so that can happen. So what are you going to do? You're going to do some cropping. As you can see on the second box here, you crop the image. So we assume the center crop is the way, but you can imagine you can actually implement different approach, like random cropping or some user-defined cropping based on how well you know the person who's taking those pictures, right? So some thinking around there. And then you resize it. And the reason you resize it is because most convolutional neural network, which is super good as classify this type of pictures, they tend to require fixed input size. So you almost always have to resize your image, regardless you're using a super good iPhone or some other mediocre cameras to take those pictures. So always resize, and then you do the random split. So for those of you who are not familiar with the supervised learning, is you always have to train it, you always have to test it, and you want to make sure you train and test, there's no leakage. That means you are not cheating. You're not using the pictures that you already seen in your training data to show up in your testing data, because that's like you can memorize things instead of really learning the robust information there. You generally do random split, and you take 80% of the data. You always want to do more for training to learn more of the inherent structure of your data, and then you do the testing, which is 20% in this case. So let's just pause for a second and try to see, okay, what are the steps I'm taking here, okay? Because this is basically the data part as you are correlating with what I mentioned about the machine learning lifecycle at the first stage. So this is the data. This concludes the data part I'm talking about. And then what I'm doing here is, okay, I'm going to let the data scientists to define a model, whatever crazy model or easy model that was defined through TensorFlow, PyTorch, even scikit-learn, and then you put into this train statement or fit, depends on what framework you're using. What this process basically means, okay, I tell the model what the labels, what is 0 or 1 is cat or dog, and then I reinforce that connections through this middle part of the convolutional neural network memory. So you heard about neurons, and neuron has memories. So that's how this whole training process works magically behind the scene. So what did I do here? I do some cropping, I do some resizing, I do some random split, and then I define my model and train my model. So that's basically my approach of dealing with this classification problem of cat and dog. So let's take another look. Like this is in the pet industry, right? Let's look at like this transportation industry. This is also a real world problem where servicing one of our clients, they want to know, they want to ID that each vehicles in their fleet. They want to ID those and then linked the goods they're carrying on that truck or car with the identity of the car. So in this problem, it's a very different problem, as you can see, because first of all, it's cars, not cute pets anymore. The other thing is the area you're looking for, which is the license plate, is what we call it identification, is way smaller than the previous case where your dog and cats are kind of taking the majority of the field view. So then you might wonder, how am I going to reuse what I have built before to tackle this new problem? Am I going to build everything from scratch? So that's what I'm going to show you here is, so once you have that concept, congratulations, I think that's the first step you want to do, is you always pound on what reusability I have in my portfolio of solutions I can reuse. The first step in this case is we call it region proposal. Region proposal is by itself is a research area. There are so many papers talking about how I can propose the regions I'm interested in. In a brute force way, you can do sliding window, like you can just slide different regions and try to go from there. Another option, like what I'm doing here, is I just random crop something, and with the hope that the plate is somehow incorporated entirely in my region proposal. So once I do that, I actually converted that to one of the problems I'm familiar with, because I can do the same resizing, I can do the same trend test split, and then now you know that you define the model, you kind of reinforce again the labels and reinforce the memories of this convolutional neural network. You might as well just use the same model definition as you were using for cat and dog. All it cares is about the memories or the weights of those neurons. So if you're lazy as me, I would just use the same model architectures and just to throw into this training process. And if you were to compare with what we did before on the cat and dog problems, the difference is that you're looking at a region, the actual step of region proposal, and then the rest of things are pretty much the same. You're doing a resizing, split, define model, and training model. So this is really a toy problem that is probably so trivial for people who are running their day-to-day machine learning task. So to make it less non-trivial, this is what's actually behind the scene. We actually implemented this full unified image and object detection category of support in this in our product. One of the product in our product portfolio is that you can see this imagery data. I want to clarify, all the yellow boxes are kind of either user input or it's an entity or storage kind of related. And the green boxes are the kind of the APIs or some you can consider as a function or wrapper that will do the job by itself. And the red arrows are the kind of what type of input from that yellow boxes are needed need to go through those different APIs. So without too much of an intimidation on this fairly complicated diagram, what you can actually see some familiarities to what I talked about before, right? You are doing some pre-processing. In this pre-processing, we're incorporating more of the capacities way richer than what I showed before about resizing and cropping, that kind of thing. You actually do a lot of image augmentation, which is very common in computer vision space. So I'll just start from there. Like the imagery data, I don't really care about where it comes from. We have handlers to handle where the data are stored on-prem or on AWS S3 or on GCP, GCS. I don't really care. We can handle that. The major part in this whole process to me is really the configuration API. We're really hoping to have the user to only click one button and have a centralized place to input their requirements, then really clicking through different buttons like you're doing in your Jupyter notebook. It's for practitioners, that's fine, but for some of our business users, it can be a little bit cumbersome when you think about, okay, I have to do more than I need to do. So that's kind of the centralized place where you can define your task type. It's either an imagery classification or it's an object detection problem. Or do you want to specify some of the other hyperparameters you want to choose, or just let the product to kind of choose by itself? And one outstanding thing I want to mention is as much as we want the user to have the flexibility to input their own configuration, we also have a lot of default setting just to make this as easy as it can be, because we know some customers like, yeah, we trust you can select the best you can. I don't really have a preference, so we want to suit that needs as well. So if the user does not define, we'll just recommend the best parameter settings so that the user will get really one button away from what they were looking for. And then this typical model training API encompasses different small APIs on the training and evaluation, and then the model artifact is saved to the design location, which is also defined by this configuration API. So this is basically our solutions, and we actually have different portfolio items. I call this one of the portfolio, but I was giving a talk on the other week where one of the audience members asking, how about the other task in computer vision space, for example, the segmentation. Unfortunately, for segmentation, we have it in a separate product portfolio that does not fit in this space, just because in segmentation space, you are looking for pixel level, that kind of granularity that is really hard to fit in this overall workflow. So that's something you really need to think about when you want to design a system like this. How are you going to assess the level of generalization or reusability so that you have the right balance of, yes, this problem, this system is just so generic that I have to do a lot of tedious manipulation versus I just want this to solve a particular problem, then it becomes overwhelming of a product portfolio. So that's learning. So try not to make this of a sales pitch, because I'm a data scientist by training. I do want to highlight that this life cycle is an iterative process, and it requires expertise across disciplines. And I want to iterate more that this it's hard to find a unicorn where you kind of know all the toolings and the handshake process through data, model, and deploy. That's what we feel like in order to really improve the team productivity, a good approach would be you make those portfolio items across this as easy to use. Even we are opening our product to our internal development team, so they, without just too much of diving deep into, hey, what exactly the model want, this data engineer can just go through themselves and explore that conveniently, and we're really seeing the efficiency in delivering end-to-end solution through this approach. So that's kind of a little bit of secret sauce of how we are really augmenting the team's deliverables without really hiring so many unicorn person. So I think I want to add a little, contact thing, and feel free to chat with me on this different connecting approaches. And with that will conclude my presentation. I want to open up for any questions as well. I'm sure there's experts in this room are wondering about different things. So thanks, everyone. I want to get your question, Chris. Your question about what's the best strategy to test the model as it's part of the offering of the integrated software system? Yeah, I think that's a really pain we were experiencing as well as machine learning try to mingle with the traditional software space. It's definitely a lot of, I often see people like the same project team and they were talking and they don't really know what each other is talking about, and there are so many terminologies in this modeling space are very unique to this space, then it becomes a disaster with a lack of productivity. So this is exactly what we're trying to address here with this relatively integrated framework. Is you try to standardize the model input and output. I don't know if that makes sense, because I don't really care. I mean, for deployment side or software side, you don't really care about if it's TensorFlow model or PyTorch model or scikit-learn model. There should be a standard format when the handoff or your ML engineers are thinking about, right? So think about what the type of model output is that going to be a continuous output, or it's going to be a discrete output? It will be numbers, or how would that look like? So try to challenge yourself on is there common standards you're trying to categorize those different output that you can work with your ML op team to agree on that kind of format. So that's something we find very, very useful. And the other thing on the data side, which is really on the upstream side, is we really mingle the data engineer and the data scientist together in various projects and settings, where when data engineers are kind of building their data models, we will make sure the data scientists is also in the room. So they are like the stakeholders to some extent, that they need to have a voice on how you design your entity mapping and how you define your nodes in a graph context, how you define your nodes, what kind of relationship I want this data entities to with each other. So that's another thing we're keep pushing towards that end. So your question is about the automated strategy testing of the models. So a good question. So when we are doing, besides the regular unit test where you're kind of try to make sure you're doing the thing you want to do for each of the things, we normally use PyTest to kind of deal with those small blocks of modulars data scientists are developing. That's kind of I like it. I think it has a very convenient plug-in and not too scary for data scientists. So yeah. Yeah, so besides this PyTest, we also want to, sometimes testing can be a nightmare for developers, because sometimes we feel like we actually wrote more testing scripts than the actual the software itself, right? So that's good, because you're trying to have enough coverage of what your function can handle, so you're really iterating your features in what you are trying to offer. But there's this, to me, I feel like it's actually involves with how much of a business need you want to cover the type of modules you want to support. That's actually connects to even upstream. Outside the screen that can fit is the business sides of need. So that's another challenge you definitely can factor in. Yeah. So I think in general, I'm really glad that you're asking that question, because that's something even our clients were not really. We have to educate our clients to tell them, hey, you want to make sure whatever you put into the production are actually doing the right thing, and there's some cadence you need to factor in. So there's different approach from math or statistical point of view, some distribution-driven, statistical-driven kind of thresholding or metrics you can kind of embed in your typical cadence of checking. So that's something you definitely want to do. Another thing is we found successful in one of our applications is you actually build that continuous learning in your model. So there are different models, in particular for forecast models, and those, in particular, those time series. You should be able to allow the model to absorb new data as it corrects what it has predicted in the past. So the model architecture itself is actually allowing that continuous learning just by choosing the right architecture and algorithm. I don't know if that makes sense, but we can chat more. This is a very interesting area, and we would hope we will be doing more interesting innovations. Yeah, so that's a good question. I was at Google Data and AI, so I'm going to borrow some of that because I agree with what Google said 2 weeks ago, for the most part. One of the trend is code-free. So it's really try to open up a playground for business stakeholders to get their hands dirty, but not really too deep into the weeds, but they're able to prescribe their business requirements through some of the automated process. So that's actually in line with what we're doing here as well, as you're thinking about we take care of 90% of the work, and the user just need to input their requirements, and one button away, they're getting what they want. For example, in some of the softwares, both AWS and GCP provides, they actually does a lot of SQL query behind the scene, and also some of the tabular software, I think, is still in R&D, I'm sure, but I met their R&D director, and they were actually saying, okay, please give me what's the trend for the housing price in San Francisco in next 10 years. You just do that in NLP, so that you can imagine a lot of NLP going on at the back of it, and you are seeing a pretty dashboard that what's happening behind the scenes is pulling based on the sentiment analysis of what I say. It does the query of the data and SQL, whatever, and building some analysis behind the scene. It does that all by its own. And you don't really, all you need to do is to say what you want. So I think that's pretty cool. I'm not sure if that's integrated to the tabular product offering yet, but that's definitely one of the trends is no code or less code. Another part in terms of the trend, which I think is very interesting, is to more emphasizing on the human in the loop. So human in the loop, for those of you who are familiar with this annotation, is you actually allow the user to interfere with how machine learning is working. So the human in the loop becomes a very popular concept ever since. And now in this business setting, sometimes the domain knowledge can be too nebulous to capture in a typical machine learning setting. So what you want to do is you allow the SME to interfere the process whenever the person sees some abnormal things, and he or she can actually interfere and override what the machine learning model predicts or is trying to do. So, and everything is fully transparent in that space. So I think that's a really cool thing. I'm also going to explore in our product development career as well. Cool, I think. About the time. So thanks for everyone's attention, and have a good lunch, and have a good weekend as well.